In semiconductor manufacturing, even the smallest impurity can destroy wafer yield. Liquid chemicals like isopropyl alcohol, critical for cleaning and drying of the wafer, can carry invisible contaminants that form defects at the nanometer scale. Defects often originate from native particles or precipitated precursor particles. When dissolved contaminants are distributed in a liquid, their particle volume is directly proportional to droplet size. So, when the concentration of precursors increases, the resulting precipitated particles grow larger, posing a higher risk to wafer surfaces. Nebulization recreates this exact phenomenon, mimicking the formation of droplets left on wafers after spin drying. Traditional optical particle counters, or OPCs, have fundamental limitations. They rely on laser light scattering, detecting particles only when the refractive index contrast produces enough scattered light to register a signal. However, as particle diameter approaches 20 nanometers, the scattering intensity drops to nearly zero. This means OPCs cannot detect the smallest, yield-killing precursors dissolved in the liquid. They're also prone to measurement interference from bubbles, liquid chemistry, and refractive index variations, making calibration liquid-dependent and unreliable below 40 nanometers. In short, conventional OPCs can't see what really matters. The Scanning Threshold Particle Counter 3 from Kanomax FMT overcomes these challenges with a revolutionary measurement approach. Here's a step-by-step description of how this is done. Step 1. Nebulization. A small sample of ultra-pure liquid is introduced into the nebulizer, where it's converted into a fine mist of microdroplets, just 2 to 3 milliliters per minute. Step 2. Large droplet removal. Dual impactors remove oversized droplets that could contain multiple particles or large non-volatile residue particles, ensuring that only representative fine droplets continue forward. Step 3. Evaporation. The volatile solvent, such as IPA, is evaporated, leaving behind only the particles and non-volatile residue for measurement. Step 4. Condensation and detection. Inside the condensation particle counter, butanol vapor condenses on the particles, growing them to detectable sizes. The result: engineered aerosolization followed by size-selective condensation growth, providing quantitative nanoparticle measurement down to 3 nanometers. The STPC3 simultaneously measures native particles, organic and inorganic precursors, and precipitated non-volatile residues. This comprehensive detection provides a complete picture of contamination, well below the limits of optical methods. For example, here is a comparison of 2 different isopropyl alcohol samples, with an initial baseline of ultra-pure water. Looking at just the 15 nanometer and above particle counts shown in blue, the 2 samples look very similar and could be graded as the same quality. This is a similar measurement. Results from an optical particle counter that has a detection limit of around 20 nanometers. However, looking at the larger than 9 nanometer particle count in yellow and the larger than 3 nanometer particle count in red, it is clear that the first IP sample has significantly lower particle and non-volatile residue counts and is a much better grade IPA than the second sample, with the smaller single-digit nanometer feature sizes on the most advanced wafers being produced today. This reduced particle counts in the 3 to 15 nanometer range, and the non-volatile residue can significantly impact wafer yield. This advanced measurement is only available with the Kanomax FMT STPC3 particle counters. The STPC3 can be deployed across the entire chemical supply and delivery chain to safeguard product purity, at the chemical supplier for final production and batch certification, at the point of supply for incoming quality assurance and filter performance tracking, along the delivery system for inline filter monitoring and contamination control, and at the point of use, ensuring the final chemical that touches the wafer meets the highest purity standards. Continuous monitoring prevents cross-contamination and protects yield in the most advanced fabs. The STPC3 measures both non-volatile residue, the particle precursors, and native particles, far below the optical particle counter detection limit. In summary, it delivers exceptional sensitivity, detecting down to 3 nanometers, comprehensive monitoring for ultra-pure water, IPA, hydrogen peroxide, ammonia, and hydrochloric acid, and other ultra-pure chemicals. Versatile applications, supporting system validation, filter assessment, and compliance with SEMI C79 and C93 standards. For semiconductor wafer fabricators demanding absolute confidence in liquid purity, Kanomax FMT's STPC3 provides the most advanced nanoparticle measurement capability available today. See what others can't. Kanomax FMT, the ultimate measurements.